Let's take a look at opens and shorts in this circuit here. Now we know that when resistors are in parallel, they do something different than when they're in series. In series, we just add them all together. In parallel, we have to use a reciprocal formula where we reciprocate each resistor, get its value reciprocated, add it to the other resistor's reciprocal value, add it to the other reciprocal's resistors. Wow, that is really hard to say late in the evening. So we're going to take 10 and get its reciprocal. We're going to take 25, get its reciprocal. We're going to take the other 10, get its reciprocal. We're going to add all those together, and we're going to reciprocate that value. And we know that value should be less than 10 ohms, or we did our math wrong. So the answer to this is those three resistors, the 10, the 25, and the 10 in parallel, come out to a 4.16666 continuous ohm resistor. So we know that the total current is 2.87 amps. Now, total current is only flowing through this part of the circuit and this part of the circuit. Once it gets here, it splits. Part of the current goes through this 10 ohm, part of the current goes through that 10 ohm, part of the current goes through this, and then they start meeting back up and we get total current through these areas. So if we do the math, we should come up with somewhere close to 2.87 amps. And if we watch our indicator there, that's exactly what we're seeing. So this is a working, simple parallel circuit. We've looked at series, now we're going to look at a simple parallel. We're going to start with the opens. So we know that anytime we have an open here in our parallel, it's going to have a little different effect. The more we have in parallel, the more loads we have in parallel, the higher our current. But if we lose one of those loads, our current drops. So we would expect that if we open this resistor, and the way I'm going to open it is I'm just going to remove it. And we can see current is still flowing because it's still leaving our source. It's getting here and going, can't get back to source, not going that way. So it says I can come through here and get back to source, and I can come through here. So we have basically just a 25 and a 10 ohm in parallel. So let's figure that up and see what the total resistance is and get that. And we know it's going to be something lower than 10. And in fact, it's going to be 7.14 ohms. 7.14 ohms. We're going to divide that into 12. If I can make my calculator do what I want, 1428. And we're going to get approximately 1.68 amps. The current went down just like we said it would. It's just like unplugging an appliance in your home. All your loads in your home are in parallel. So if you start unplugging things that are on, your power consumption is going to go down, and your power bill is going to go down. And if we hover over where we're getting total current, we can't go to the individual branches because we're getting branch currents there. Got to go to where we're getting total, and we're expecting to see about 1.68. And there we go. So we've got a functional circuit here, even with one open. So the question is, can we have more than one open? Yes, we can, and we'll get to that in a minute. Now, obviously, I took out this 10. It should be no surprise if I take out this 10, we're going to have the same value because we had a 10 and a 25 down here. Now we've got a 10 and a 25 up here. So the math is going to be the same, and we're going to see that same 1.68 amps of current, and we do. So I'm going to put that one back, and I'm going to take out the 25 this time. We'll open it up. And again, we still have a pathway. We can leave our source, go through this 10, and come back to our source. We can leave our source, go through this 10, go back to our source. But we can't leave here. There's no pathway back to our source because we haven't opened. We haven't opened here. So I know the answer here, but I'm going to calculate it. Our resistance is 5 ohms. So the reciprocate 10, add it to the reciprocal of 10, reciprocate that answer, and we're going to get 5 ohms. So we're going to divide 12 volts divided by 5 ohms, and we're going to get 2.4 amps. So we should read 2.4 amps here in our value as it increases. So there we go. So Ohm's law is holding true. It wouldn't matter if this was a DC or AC source. If we've got a 12-volt source and we do the math, we're going to get it. Now, a short in parallel is a much more catastrophic event. Everything in our branches is connected to the source. So if you remember from the previous video, I said if we ever shorted the source, that would be catastrophic. Well, these are all connected to the source. So essentially, if I short across this 10 ohm or 25 ohm, we'll do the 25 ohm. I'm drawing a wire here, and I'm on short across my 25. But if you look, I'm also shorting across my 10. I'm also shorting across this 10, and I'm also shorting across my source. Now, you may be asking, what do you mean? How can that be? I'm putting a wire that connects this point to that point. It also 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 connects this point to that point. Ultimately, I'm shorting my source because electrically this point, this point, this point, and this point are the same. And electrically this point, this point, this point, and this point is the same. So if you short an electrical pathway in a simple parallel, you're basically shorting all the pathways. Resistance is going to go to near zero, current is going to go to maximum, and we're going to either burn up the wire that's carrying it back to the source, or we're going to damage our source, one of the two. So that is simple parallel. So shorts are a little different here than they were on series. So need to understand how the current flows. I think seeing this current flow back and forth can help you do that. So I'll remove our short, restart my pathway. But if you look, this point right here is electrically connected to here, 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 and here, which goes back to our source. And this point right here is electrically connected to here, 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 and goes back to our source. So it doesn't matter if I short across the 10 ohm, the 25 ohm, or this 10 ohm. I'm effectively shutting down our source. I'm shorting our source here, and catastrophic events will occur. So that shorts and opens in a parallel circuit.